Hello and welcome to this course EE101 or Electrical Circuits 1. My name is Cesar Manalo Jr. and I will be your teacher for this course for the entire term. Um, so to begin with, let's discuss the coverage of the course as covered by the course syllabus. Um, you can access this syllabus from your Blackboard by going to the course information, and then from there you can click and download the syllabus. Okay, so going back to our core syllabus, so on the first week the discussion will focus on the introduction to electric circuits, where we're going to define an electric circuit and the variables and parameters associated with an electric circuit, and what makes an electric circuit, what are the elements uh, that comprises an electric circuit. We will define variables such as voltage and current, what do you mean by volt, what do you mean by ampere, and so on and so forth. And then on the same week, we'll also cover resistance. Um, what makes a resistance, how to measure resistance, what are the factors that affects resistance of a material. Now on the second week, we'll cover resistive circuits. So these are circuits that consist of um, resistors. So we call them resistive elements that are excited or are driven by constant sources, either voltage or current sources. Uh, in this topic, we'll also cover the concept of voltage and current divider principles, and also the concept of Ohm's law. While you might have taken this in your senior high school days, it would be appropriate to review the concept of Ohm's law. And we'll also include how do we simplify a complicated resistive network into a single resistance or an equivalent resistance, including networks where Y and delta connected networks exist on those networks. Now, on the third week, we'll cover the fundamental methods of analyzing DC circuits. This topic will cover Kirchhoff's laws, voltage and current laws, and also the nodal and the mesh techniques in dealing with these circuits. That will extend up to the fourth week, and the fourth week will culminate with a preliminary course assessment to test our knowledge of the covered topics. Now, on the fifth week, uh, we'll study the different theorems associated with circuit analysis. So these are additional tools that makes the analysis more simpler and easier. So theorems like Thevenin's and Norton's theorem will be covered, including the concept of maximum power transfer. We'll also cover um, source transformations and superposition theorems. Now, in week six, we'll discuss op amps. So these are devices that are commonly found in circuits, no, particularly electronic circuits. So we'll we'll see how these devices fits in an electric circuit and how do we deal with them in terms of their behavior and uh, the analysis of circuits that involves op amps. Now on the week seven, we now look into other circuit elements like inductors and capacitors. So we call these elements energy storage elements, and uh, we'll cover first how these devices are constructed, what is their behavior, and how they store electrical energy. How do we um, treat uh, these elements, this network of elements, where they are connected in either series or parallel? So how do we treat them and how do we simplify them? And that will cover until the discussion will cover up until week 8, where that week will end with a midterm course assessment. Now, on the ninth week, we'll uh, cover circuits where it is not only they are not only resistive circuits, but these are circuits that contains resistive and energy storage, resistive elements and energy storage elements. So we will see how the circuit behaves with the different elements now in place on those circuits. First, we'll cover RC series circuits. How do you analyze those circuits? Uh, what is the complete response of those circuits that contains resistive and capacitive elements? Then that will be followed by series RL circuits. Again, we'll examine how they behave and what are the effects of the inductor, the inductive um, characteristic of the circuit, how does it affect the complete response of the circuits. And finally, we will combine the lessons learned from the RC and series RL circuits and see how we deal with circuits that consist of all those elements, the resistive, inductive, and capacitive elements. Uh, we will not be only talking about simple series and parallel circuits involving RLC circuits, but if time allows, we'll also uh, cover series, parallel, and uh, series parallel networks involving resistive, inductive, and capacitive elements. Of course, we'll examine, we'll test your knowledge on the 12th week where we will conduct our final course assessment. For your textbook, we recommend the book Engineering Circuit Analysis by Height and Kermely. Uh, this is published by McGrew-Hill Education. There's actually an online ebook available from the internet. But if you have the opportunity, we'll also may have access, online access to McGrew-Hill Connect. So this is a facility where we are able to have access to knowledge pertaining to engineering circuit analysis. So in that online access, there is an ebook there where you can access and read and practice exercises. There's also a facility there that allows us to use one of their AI systems is called the Smart Book. So the Smart Book allows, so it's like a tutor where when you use it, it adapts to your learning capacity, how fast you learn. So it adapts to it, and in effect, it uh, gives an optimum learning environment that is helpful in uh, in your in learning pertaining to this course. Now there are other references, and you may use these references. There are available references also in the library and even online in the internet. I also recommend a book by Alexander Asadico. I think that is the fifth edition of the book. Now, that can be downloaded from the internet. For our course requirement, the three major assessments will consist of 60% of your grade, and the rest will be broken down by 20% in quizzes, 10% seat work and homework, and 10% class participation. Um, the school policy will be applied, um, and I will be posting my schedule as well in the online in Blackboard, where you can see my vacant period and for your so that we could collaborate in terms of your concerns and issues that affects your class standing. So I will be posting them in a couple of days. Okay, and of course, your attendance will be monitored, and as usual, you have a maximum of seven absences, and beyond that, you may fail depending on the severity of your attendance, of your absences, I mean. Okay, so I think that's it for the introduction of this course, and on our next video, we'll be starting on our topic on the fundamentals of electric circuits. So I'll see you in the next video. Thank you.